Here are some vocabulary and formulas we need to be familiar with for dealing with velocity. So velocity is displacement of an object in circular motion with respect to time. Positive displacement is counterclockwise and negative displacement is clockwise. Speed is distance divided by time without consideration for direction. It's basically the same thing as velocity, but we don't care about the direction, so we just make it positive, which is why we use the absolute value. Displacement can be represented by arc length, how far something is going in circular motion. So of course we just learned this formula, S equals r theta. There's two different types of velocity. We have angular velocity, which is represented by the Greek letter omega, and that's where we have a change in angle over time. And then we have linear velocity, which is the length of the arc over a specific time. And these two quantities, angular and linear velocity, are related to each other by this formula. Linear velocity is the radius times the angular velocity. So if we want to convert between them, we can use that formula. Okay, let's look at some examples. Assuming that the surface of the Earth is a sphere, a point on the Earth can be thought of as an object traveling on a circle that completes one revolution in approximately 24 hours. The path traced out by a point during this 24-hour period is the latitude of the point. Salt Lake Community College is 40.7608% or degrees north latitude, and the radius of the circle of revolution at this latitude is approximately 2,999 miles. Find the linear velocity in miles per hour of Salt Lake Community College as the world turns. Fun. Okay, so we're finding linear velocity. So we know that linear velocity is related to angular velocity by doing r times omega, right? We just saw that formula. Okay, so we need to find omega. So omega can be found by taking the angle over a certain period of time. So in this case, in one day, we have one rotation of Salt Lake Community College all the way around. So that would be a complete rotation of 2 pi, correct? And in that time frame, it's one day, so it's 24 hours. So that means that omega would be pi over 12 radians per hour. Okay, so now we're going to take our velocity, linear velocity related to angular velocity formula, and we're going to take the radius of the Earth. So if you go around the Earth where Salt Lake Community College is, but the radius from like the middle, you know, like where the poles line up, to where Salt Lake Community College is. So that would be approximately 299. So that's the radius we're going to use. So 2999 for our radius, and that's in miles. And now we multiply that times our omega, our angular velocity, radians per hour. So that would be pi 12th radians per hour. If you want, you could put like the hour unit. You don't really need the radians unit because radians is just directly related to the radius. So by putting the radius in there, using radians is what calculates this correct answer for us, because radians are a radius length. So it works out to our units being miles per hour without worrying about radians because of the radius. So we have 2,999 times pi, and then we divide by 12. So how fast is Salt Lake Community College, and thus us probably, it's probably not much different where we are here. How fast are we going? Without even realizing it, by sitting still. Yeah, isn't that crazy to think about? That this is happening and we don't even know it because it's just part of our world. It's just part of what's happening. It's very, very interesting to me. Okay, does that make sense? So there's an example of just using that little linear velocity from angular velocity and radius formula. Okay. An old vinyl record is played on a turntable rotating at a rate of 45 revolutions per minute. So frequently those are just called RPMs. Find the angular speed in radians per second. So this is where I'm going to use conversion factors to do this problem. So I'm going to set this up carefully with a bunch of fractions and units that will cancel out as I go along. So I've got 45 revolutions per minute. That's the speed of a 45 record. We want to change our answer to radians per second. So we need to change our revolutions to radians. Yep, so 2 pi radians in 1 revolution. Good. So we've got our radians and their revolutions cancel out at this point, right? But what else do we need to change for this to work? We need to change our minutes to seconds. So minutes is on the bottom here, so we need minutes on the top. So 1 minute is 60 seconds. That puts seconds on the bottom. My minute units cancel out. So now to find the answer, I've got 45 times 2 times pi divided by 60. Maybe we want to leave our answer exact, actually. Yeah, let's plan on leaving it exact. So that would be 90 pi. We can do it both ways, both exact and approximate. So what does that reduce to? 3 pi halves radians per second, right? Or approximately 3 times pi divided by 2 would be approximately 4.71 radians per second. Now in my head that doesn't really make, like, revolutions per minute honestly makes more sense than radians per second. So I feel like this would make even more sense to me if I changed that to miles per hour, right? But that would take knowing the radius of our record. We would have to know the radius of it. We would have to know, we would have to be able to convert to hours instead of, we went the other direction, to seconds. Like, there's a lot more information involved to change that to linear velocity instead of just angular. All right, last example. This is a good problem.